Hello, this is Diana Bias with the Batman Curve, and this project was made by myself, Diana, and Destiny Pignon. So in a previous video, we showed you the Batman Curve and all the different piecewise functions. So as you can see, we have the ellipse for the black. There's a different piecewise function for the bottom, one for the magenta, one for the green and the blue and the yellow. And this is the basic of the Batman Curve. For us to find the area of the Batman curve, we will take the area of the first half and then the second half. So for the top half, we have the equation f of x equals h minus l times h of x plus 1 plus r minus h times h of x minus 1 plus l minus w times h of x plus 3 plus wr times h of x minus 3 plus w of 1 half. And then the 1 half, it multiplies all of this as well. And just to save us a little time, I will not say all of it. But this is basically the top half of our Batman. So if you look at this, it is the blue section. Afterwards, we have the bottom half, and the bottom half is a lot simpler. As you can see, it's g of x equals x plus 4 over the absolute value of x plus 4 minus x minus 4 over the absolute value of x minus 4 minus 3 times the square root of 1 minus 1/7 x squared. And then these are all of the explanations of what each of the letters mean in the first equation of f of x. And so as you can see, h is a piecewise function, w is 3 times the square root of 1 minus x squared, l is 1 over 2 times x plus 3 minus 3/7 times the square root of 10 times the square root of 4 minus x plus 1 squared plus 6/7 times the square root of 10, and so on. The one thing that we could not figure out was why this f was here, and so we tried to look it up online, and we could never figure it out. It was very difficult for us to figure it out, but we did find the actual equation of the area for the Batman curve. And so what we did, we calculated it from that, and I will show it on the next page. But what we did is, for x, we plugged in 2, because as you can see here, if x was anything less than 2, it would not work, because it would give us a 0 under here, and this equation would not work, making this equation false. And so the area was 955 over 48 minus 2/7 times 2 times the square root of 33 plus 7 pi plus 3 times the square root of 10 times x minus 1 plus 21 times the cosine raised to the negative 1 times 3 over 7 plus cosine to the negative 1 of 4/7. So the actual area of the Batman curve after using the above equation is 51.5186737336, or around 52 square units. Alright, so that is all for the area of the Batman curve.